We're going to start our work now with solving triangles, and in this lesson we're going to work with what's called the law of sines. The triangles we're going to work with in this section are not necessarily right triangles. Let's look at our first example. We have triangle ABC, which is not necessarily a right triangle, in which angle A is 50 degrees, angle B is 60 degrees, and side A is 36 kilometers. We want to find the measure of angle C, and then we want to find the measure of side C. So I'm going to start this problem by drawing a triangle. It doesn't have to be very accurate. I'm just going to use it to label the information that I'm given. Here's angle A, angle B, and angle C. I know that angle A is 50 degrees, so I'm going to label this angle with 50 degrees. Angle B is 60 degrees, so I'm going to label that 60 degrees. And then side A is 36 kilometers, so I'll label this with 36. Now, I have my triangle right here for reference, and I've labeled the information that I'm given. And now I'll look and see if I can find angle A first, and then after that I'm going to find side C. So let's start with angle C, and this is what I have. C will be 180 degrees, subtract the sum of 50 degrees and 60 degrees. That's because the sum of the three angles in any triangle have to add up to 180 degrees. So I have two of them, 50 and 60. I'll add those up, subtract from 180, and I'll have the measure of angle C. So 50 plus 60 is 110. 180 subtract 110 is going to be 70 degrees. So angle C is 70 degrees. And so I'll label my triangle over here with 70 degrees for angle C. Now the next thing I want to do is find side C, the length of side C, so that's right over here, opposite angle C. And to do that, I'm going to use my law of sines. So let's do that next. So what I'm going to say is this. C is to the sine of the angle opposite, which is angle C. So C is to sine 70 as, I'll take this ratio right here, 36 is to the sine of 50. 36 is to the sine of 50 degrees. Now that is what we call the law of sines. And the law of sines says that the ratio of any side to the sine of the angle opposite is constant in any triangle. So C is to the sine of C as A is to the sine of A. So I have this ratio filled in right here with three of the things known and one unknown. It's very easy to solve for the unknown. I'll multiply both sides by the sine of 70, and so I'll get C is equal to 36 sine 70 degrees, all divided by the sine of 50 degrees. Now, if I do this on a calculator, which I've already done, I'll just show you the first few digits here. It's going to be 36 times 0.9397. That's the first four digits of what I get if I find the sine of 70 degrees on my calculator, divided by sine 50 on the calculator is going to be 0.7660. I do the arithmetic on my calculator, round off using my significant digits here. I get 44 kilometers for the length of side C. So I use my law of sines by setting up these two ratios. C is to the sine of 70 as 36 is to the sine of 50. Then I use a calculator, work all this out. I end up with C is equal to 44 kilometers. So I've succeeded in finding angle C and then the side opposite that. Let's look at another problem. We have triangle ABC with angle B is 13.4 degrees, angle C is 24.8 degrees, side A is 315 centimeters, and we want to find all the missing parts. So again, I'm going to draw a triangle here for reference. Doesn't have to be accurate. I'll label it A, B, and C. Now, angle B is 13.4 degrees, so I'll put 13.4 degrees right here. Angle C is 24.8, so I'll put 24.8 degrees here. And then side A is 315 centimeters, so I'll put 315 right here. So I need to find angle A, I need to find side B, and I need to find side C. So I'm going to start by finding angle A. So angle A will be 180 degrees, subtract 13.4 degrees plus 24.8 degrees, Do that on my calculator, and angle A comes out to be 141.8 degrees. So that's angle A. I'll fill in my triangle right here with 141.8 degrees. So you can see right away that I haven't drawn a very accurate triangle right here because this is an obtuse angle and of 141.8 degrees, and the triangle certainly doesn't look like that. But that's okay. For our purposes right here, we're using this triangle just so we can take a look at what's given to us and what we're asked to find. Now, I'm going to use the law of sines next to find the measure of side C, and I'm going to say this. The length of side C is to the sine of 24.8 as 315 is to the sine of 141.8. That's the law of sines. Here we go. C is to the sine of 24.8 degrees as 315 is to the sine of 141.8 degrees. I'll multiply both sides by sine 24.8 degrees, and I'll end up with C is equal to 315 sine 24.8 degrees, all divided by the sine of 141.8 degrees. Now, I worked this out on a calculator, and I've done that already, and that comes out to be, to 3 significant digits, 214 centimeters. So 214 centimeters for the length of side C. So if I go up to my original triangle right here, I can label this as 214 centimeters for the length of my side C right here. The only thing left to find now is side B, and I'll use the law of sines again to say that B is to the sine of 13.4 as 315 is to the sine of 141.8. So let's do that problem over here. And I'll say B is to the sine of 13.4 degrees as 315 is to the sine of 141.8 degrees. I multiply by sine 13.4 degrees both sides, and I end up with B is equal to 315 sine 13.4 degrees, all divided by the sine of 141.8 degrees. I work this out on the calculator, and again, I've already done this, and I get 118 centimeters for the length of side B. So the law of sines, as you can see, a very valuable tool in solving triangles.